All right, so thank you to everybody who's listening to this webinar. So I've been with the company about 5 years now with WeatherBond as a representative of Carlisle Construction Materials, and my name is Tony Vieira. So again, thanks for joining this. And then this particular webinar is going to be talking about really EPDM from a 101 or pretty basic standpoint, essentially. So we'll get started here, and what we see here are the basic system types. So I want to talk about these because we are going to reference these systems throughout the webinar, essentially. So it's really important to get just a basic understanding of what each of these is. So if we look to the slide, to the image to the left, that is a adhered roof system. So we reference the system name based on the way that the membrane itself is secured. And so if the membrane is secured with bonding adhesive, then it is, we reference that as a adhered system. And then if the membrane, for example, is secured with ballast, in the case it's generally rock that secures that. We'll talk more about that rock later on in the webinar, but that rock, or the weight of it, essentially is what secures both the membrane and the insulation on a ballasted roof system. And then a mechanically attached system, you can see there's fasteners and plates, kind of is what's illustrated here in this slide. And those fasteners and plates are what secure the membrane. So there's no bonding adhesive on a mechanically attached system, at least not in the field of the roof. So just to get a idea of what each of these different systems, what their names are really standing for when we reference them. And then EPDM membranes, so basically been around since the 60s. I'd say that's one of their biggest selling points is that, the biggest selling points of EPDM is that just proven performance basically over time. And it also, I think somewhere along the line, it got a little bit lost. We do make EPDM in white, but I think most people are probably used to seeing the black. And the white can definitely serve a benefit in like southern climates, for example, where you have kind of that cool roof effect, for example. So basically, because it's white, it's going to reflect some of that heat back up, so you're not gonna have as much cool air lost in the building. But you have to think you kind of have the opposite effect in like northern climates, for example, or I should say you really can have the opposite effect. So by a darker color membrane, you're essentially talking about, because of that heat absorption, you actually have like a heat gain effect when it's cold outside. And that heat gain can actually offset the cool air lost, in the cold months, for example. So if you take Pennsylvania, it's actually, where Carlisle Construction Materials is based out of. We're a perfect example of that. We actually have more cold days a year than we do hot days. So just to reference that, I think somewhere along the line that one kind of got lost in the single ply roofing industry a little bit, about the dark roof actually potentially being a benefit in northern climates. So anyway, moving on with this, we're going to talk about basically, I'm going to break down EPDM into two different categories. So you have reinforced and you have non-reinforced EPDM. So reinforced EPDM is basically what we see in this slide right here. It has a scrim that's actually embedded into the sheet itself. It's right in the center, essentially. So that scrim gives reinforcement. It basically, a couple things. It helps it with puncture resistance. The biggest thing is tear resistance. So when it comes to mechanically attached systems, so just like what this guy's doing in the image that we see right here, you've got fasteners and plates securing the membrane. No bonding adhesive in this example. What you're going to have in that instance is essentially sheet flutter. So you got to think as wind moves across this roof, these sheets can actually flutter essentially in the wind, and that is the way that the system, is designed to perform. So the problem with the membrane that does not have the scrim in it, that reinforcement we're talking about, is it's more prone, especially when you have that sheet flutter, to potentially tearing at those fasteners and plates. Especially if it gets really, really windy, for example. So that is why on mechanically attached systems, we really always want to see the reinforced EPDM membrane. And I also want to talk about just real quick that all of the EPDM membranes we're going to be talking about coming up here, they all come in different thicknesses. And the reason for the different thicknesses, of course, would be different membrane warranties, for example. So Obviously, we're going to want to see thicker membranes on different warranty lengths, for example. So just an FYI on why you see that. You'll see actually EPDM come in, you'll see the reinforced come in 45 mil, 60, and 75 mil are all options for the reinforced EPDM. And then non-reinforced EPDM, this one's easy. There's really no scrim. So it's just really synthetic rubber all the way through. And then, so this can work great on like adhered systems, for example. It can also work on ballasted systems, but this is what I was referring to on mechanically attached systems. We would not want to be using, we would not recommend using the non-reinforced EPDM membrane because of that potential tear at those fasteners and plates when it gets really windy. So the thicknesses that non-reinforced comes in is going to be 45 mil, 60, and then 90 mil. So if you remember me talking about the reinforced, it comes in 45, 60, and 75. We kind of skip the 75 with the non-reinforced. It comes in 45, 60, and then 90 mil are the thicknesses that you can get the non-reinforced in. And then the non-reinforced actually has some pretty wide sheets available, unlike the reinforced. So the reinforced actually has sheets. You can get them either 6.5 feet wide, you can get them 8 feet wide, or 10 feet wide. And really the reason why you might want to use a narrower sheet than a wider sheet would have to do with securement. So narrower sheets, for example, are going to essentially, if you have those fasteners and plates inside the seams of the sheets, they're going to be more secure than a wider sheet, right? Because you have more distance between those rows of fasteners and plates on a wider sheet. So it essentially equates to less securement in that regard. The non-reinforced, going back to that though now, that's the slide we're on, basically that comes in wider, or excuse me, you can get it 10 foot wide, you can get it actually in increments all the way up to 50 feet wide in black, so in the black EPDM membrane. So if it's a 10 foot or less wide sheet, whether it's non-reinforced or reinforced, remember reinforced only comes up to 10 feet wide, but if it's 10 feet wide or less, then it's going to be what we would refer to, really, it's a no dust sheet. Okay, so the sheet essentially has been pre-cleaned in the factory, and that actually really comes as a benefit when it comes to seam areas. For example, it makes the way we recommend doing seams a little bit easier, and I'll talk about that coming up. But I want to show you an example of a dusted sheet. So you can actually see this sheet right here. Kind of has it's almost like you can see almost like a whitish film on it, and that is mica dust that's left on that sheet on purpose. So the wider than 10 foot sheets that I was talking about, it's only in the non-reinforced that you're going to find those. We have to leave that dust on there, and the reason why is because you look at this core, excuse me, in the background here. When we ship these out, we ship them out on a core like this. We can't ship, for example, a 30 foot wide sheet on a core that's, you know, more than 30 feet long. So what we actually do is we actually fold that membrane onto itself. And when we do that, if we don't leave the dust on, if we pre-clean that off, essentially those sheets stick to themselves, and the roofer can't unroll the sheet when it gets to the job. So obviously it's a crucial step to be able to unroll the sheet. So anyway, that is why you'll see the dust left on the membrane. Now there are some a little bit of additional steps I want to say when it comes to splicing seam areas, and I'll talk about that coming up. But just to give you an instance of this, and probably, you know, you're not going to be using these really wide sheets unless it's a big job, of course. But just to let you know that if you have one, you know, they are available. So. And then the white non-reinforced EPDM, the white is only available in non-reinforced. We really don't have the white in a reinforced option, so really wouldn't want to be using the white on like a mechanically attached roof, not the white EPDM, that is. Again, because of that, it doesn't have that scrim reinforcement. But we do have the white in 60 and 90 mil are the thicknesses that it's available in. And then again, you have the benefit of potentially having a really more cool roof if you're in like hotter areas or hotter climates, for example. And then we do also, I want to note, have all matching accessories when it comes to the white EPDM membrane. So if anybody's familiar with like our roofs call them pipe boots, essentially they're used to flash a pipe. We have those in black and white is what we sell them in. So that's just one example of an accessory product that we manufacture in the white. So our uncured flashing, for example, that is in white as well. So all the same components, or all the same accessories, I should say, is that we make in the black. For the black membrane, we have in the white as well. So, okay, so membrane, and by the way, for the white, we do have those in 10 feet wide sheets. We have them in 16.5 and 20 feet wide sheets. So again, the 16.5 and 20 feet wide, those are going to be dusted sheets. And then for membrane securement, this is just kind of a lead-in slide to where we'll talk about actually securing the membrane itself. We're going to get into more depth though. So this is, you remember me talking at the very beginning about an adhered system being where the membrane is actually attached with bonding adhesive. It's important to really note that for an adhered system, for example, what you see right here, this is a bonding adhesive is what we refer to it as. It's a membrane adhesive. And this is a two-sided contact adhesive. So it relies on essentially contact. So you actually have to apply it to both the membrane and the substrate. And that's really the most common adhesives we sell are going to be contact adhesives. So really right here, what we're doing is we're just taking a picture right here, an image, and then we're taking it to real life. Okay, you can see the dark areas of adhesive where they've applied it to the substrate. And by the substrate, I'm talking about what the membrane is being adhered to. So in this case, it's the insulation. And then you can't see it as well on the membrane, but it is also applied to the membrane itself in this image. So just some examples there. And then probably just real quick to reference that you don't want to, and I mentioned this in the Insulation 101 webinar, you don't want to intermix insulation adhesive with membrane adhesive. So this being bare membrane or bareback membrane, we don't want to use the flexible dash adhesive to adhere this to the insulation. It will not work as well. And just as like we don't want to use membrane adhesive, stuff we see in these yellow pails, we'll talk more about that in the next slide. We don't want to be using that to adhere insulation either to the deck or to other layers of insulation, for example. So just an example of that right there. So the adhesives that we see in this slide, these are really, a lot of people refer to them as solvent-based adhesives. They're a lot of people refer to them as our standard adhesives. And these are contact adhesives, essentially. So these need to be applied to both the membrane and to the substrate, like in the last image that I was showing. So with these, I'll talk about really just the difference first. So the X23 low VOC bonding adhesive that we see in the left-hand image there, that is a low VOC adhesive. So in certain states, they are mandatory to use low VOC adhesives. So if you are in a state like Pennsylvania, just as an example, between these two, you would really need to be using the low VOC version. I know Ohio, for example, where I did a lot of work in for a little while, at least it was about 2 years ago, so to my knowledge, they're still the same, but they allowed the adhesives that were not low VOC. So you could use the LC60, for example. Now, the low VOC adhesives are going to be a little more expensive, so that's the primary reason that a roofer wouldn't use them if they weren't in a state that made them mandatory, for example. So just to point out really the differences between these two, but from an application standpoint, from a storage standpoint, these really are the same. So that's mainly what we're going to focus on here is the similarities, because aside from the fact that one is low VOC and one isn't, it's really about the similarities between these two. So storage, you really want to store these 60 to 80 degrees is the optimal environment for these, and that really comes down to shelf life. So we say that the shelf life on these is a year. So by storing them in a good environment, you're really optimizing that shelf life. And then when you apply these, or before you apply them, you want to mix them. So you really got a couple methods to mix them. You can either use a mixing paddle, for example. It basically is it looks like you might see them used in like tiling, for example, but they look like a big egg beater essentially. You can plug those into a drill. And if you use a drill, we want to drill really, we would say to use one that does not create a spark. So either one that would work with an air compressor, so like an air pressurized drill, or a drill with like brushless motors that aren't going to create a spark. The reason why is these are flammable adhesives. So a spark getting into those while you're mixing it would obviously not be a good thing. So you want to mix them if you're using like a drill, for example, or the kind we recommend. You would mix them until they're uniform yellow in color. If you were to open up a fresh can of these, for example, you'd see like kind of almost like a dark bronze color on the top, or like a bronze color, I'll just say, on the top with either one. And what's happened is a lot of the additives have basically settled to the bottom, and we want those additives mixed in with the product for it to work properly. So you want to mix it until there's no longer any streaks between yellow and bronze, for example. You would want to see just a consistent yellow color throughout. So with a drill, that's going to go pretty quick if you have like a mixing paddle in the drill, but if you don't have that, you can also mix these manually. So you can use like a wood paddle, for example, do it the old-fashioned way. We say to basically 5 minutes if you're going to actually stir it manually like that. So you really want to scrape the bottoms and the sides of the can and really get all those additives mixed in. And but same deal. At the end of the day, what you're looking for with the result is that it's uniform yellow in color. And then with spreading these, you basically want to spread them so that it's even. And this is very difficult to obviously show on a webinar, but it should be an even coat, and you should avoid globs or puddles. And the main reason you want to avoid globs and puddles is because of what we call flash off, and we'll talk about that here in just a minute, actually. But I want to go back to spreading it. So if you spread it out, you could use like a 9-inch roller, for example. So that's what you would dip into the can and then spread it again, even without globs or puddles as much as possible. And then you can also use what's called like their mechanical dispensers. If anybody's ever heard of better spreaders, for example, those are basically those dispensers punches holes in the sides of these cans, and it essentially leaks the adhesive in strands across the roof. We don't say you can't use those with this adhesive, or we don't necessarily have an issue, I should say, with those. But what can happen, we found, is that, again, if you remember me saying that this adhesive needs to be applied in an even coat, when you use those dispensers, because it leaks them in strands, it tends to be kind of thick in the strand areas, or where those beads are. I'm using beads and strands interchangeably with that term. Tends to be thick in those areas and then thin in the areas in between. Sometimes there's actually no adhesive in the areas between those. And that absolutely can be an issue when it comes to the securement of the membrane. So what we say, even if you use those mechanical dispensers like better spreaders, you want to actually still take a 9-inch like paint roller, for example, and you actually want to go back and back roll it so that you have that even coat. So just an FYI there with those. And then when I was talking about the flash off and like the even flash off time, the other reason we want a good even coat, and we want a coat that is on 100% of the surface, the main reason we want an even coat is we want even flash off. So flash off is essentially the window of time that the adhesive is ready for the membrane to be bonded to the insulation or to the substrate, for example. There's no exact time that we give on that, on how long that's going to take. It's going to take longer with these adhesives that we see right here than it will with the product that I'm going to be talking about next. That's actually really quickly eclipsing these that we see right here. But with these, we say that you know it's ready to go, or that the window of time is when it's tacky, and we say it does not string or transfer to a dry finger or like a dry knuckle touch. If it's wet, if it's stringing or transferring, it's too soon. If it's too dry, if it's not tacky, I should say, then it's too dry. Now, if it over dries, it's not really a big deal. You can just reapply the adhesive to that area. That's absolutely fine to do that, and then wait for it to flash off. So again, what we're really looking for is tacky, shouldn't string or transfer to a dry finger touch, what we say. And then once you get to that window, it's tacky on both the substrate and the membrane. You want to mate the membrane or bond the membrane to the substrate, and then so you would actually roll that membrane in, and then you would broom it with, we say, a stiff bristle broom to really just get some pressure on it, basically. And And then that would really be the last step. You don't want to get adhesive in your seam areas. If you do, you want to clean that off, and we'll talk about what you could use to clean it here in a later slide. But I just want to talk about also temperature restrictions. We actually don't restrict temperature with these. We don't say that they have a minimum temperature, for example. If you're going below 40 degrees, we say you should keep the adhesive itself about room temperature, and that really comes down to spreadability of the product. If the adhesive itself drops really below 40 degrees, it can be really tough to spread out. We don't recommend, with me saying that, really going below like 20. 20 degrees, it tends to take a really, really long time with this adhesive to flash off, especially to get good even flash off of the product. So just a couple of notes right there. And then this is the product that I was saying was quickly eclipsing the other adhesives in the last slide. So this is our Cav Grip 3, and this is a spray-on adhesive. So you're not going to use like a 9-inch roller, for example, like a paint roller. And by the way, usually the roller people use like a 3/8 snap roller with those adhesives in the other slide. But you're not going to use that. You're just going to actually spray this. So we actually we sell the hose and the gun that you would need to spray on this adhesive separately. And you actually have a couple of different lengths that you can get that hose in. For example, you can get it in 6-foot lengths, you can get it in 8-foot lengths, 6-foot lengths, 12-foot lengths, or 18-foot lengths. Most people get the 12 or the 18. The 6 tends to be a little bit short, but the gun, you can get it basically with an extension wand or without an extension wand. I'd highly recommend getting the one with the extension wand, because that's going to enable you to actually stand up and easily apply this to the deck and not have to basically be bent over the whole time. So these canisters, or these tanks that you see, there's the 40-pound tank that we see right here, and then there's the 85-pound, I really call it cylinder, 85-pound cylinder we see on the right-hand side right here. The 85-pound cylinder, just an FYI on that, you need to order this in quantities of 12, basically, or cartons of 12, and then it actually needs to be, you can't really throw them out. There's a number on the back of them that needs to be called, and then a company actually will come and pick those up for you. But I just want to let people know that there's a minimum order quantity and return quantity on these. These right here, there's no minimum order quantity, and then you can actually, there is a punch out valve on the 40-pounder. So when that adhesive is all dispensed, you can actually just punch out that valve and dispose of it. So that's really the main difference from that standpoint. Aside from that, it's obviously coverage rate. You're going to get a lot more coverage out of the 85-pound cylinder than you are the 40-pound cylinder. So they're both contact adhesives, though, by the way. So I can't really show in a webinar very easily spraying this on, but we do have videos of this being sprayed on, just if you would want to reference those. But much, much faster, like I said, than the adhesives from the other slide, than actually roller applying it. That's really its major benefit. And then it's also a contact adhesive, if I didn't say that already. So you spray this on both the membrane and on the substrate, just like the adhesive in this slide right here, for example. So it has to go on both. If you just spray it on one, it will not bond. So coverage is, we say, 1,000 square feet per canister with one of these 40-pounders. Let me go back here. 1,000 square feet per canister for one of these 40-pounders, finished surface. Now, when we say finished surface, we're talking about finished roof area. So basically, there's enough adhesive in this canister that, let's say you had the 40-pounder, that if you had a roof that, let's say, was 1,000 square feet, you would have enough adhesive to coat both the membrane and the substrate for that roof and bond it together. For the 85-pound cylinder, you have enough adhesive in there to do about 2,000 square feet, we say. So that's really the major difference there. Now, I want to talk about temperature restrictions with these ones. We really say that this adhesive can go down to 25 degrees, but it needs to be kept over 70 degrees upon application. So that is where we sell hot blankets. We sell power blankets, their official name, and those can essentially wrap around this adhesive. You can plug those in, and those will essentially maintain the warmth of the adhesive upon application in those colder temperatures. So if you go down into, like, 30 degrees, for example, you definitely want to use those. So the other thing to note with those, I mentioned this in the Insulation 101, if you're using those power blankets, those are really not meant to bring the adhesive up to temperature. So if those canisters do get cold, which we really don't want, we want them always stored, room temperature, but if they do get cold, it takes a really, really long time for those power blankets to actually bring them up to temperature. So those are really just meant to maintain the temperature of the adhesive in these. And then if you use the 40 pounder, you would just use one of those power blankets. If you use the 85 pounder, you'd actually have to use two of them. They'd basically be stacked on top of each other and plugged in. And again, that will maintain that warmth. There is also, I'll just mention real quick, a dual connector, essentially like a coupling that comes with this. You can actually hook up two guns and hoses to one of these guys. So that comes to a benefit because you could put these tanks in like a cart, for example, push it across the roof, and you could have one roofer spraying the membrane and one roofer spraying the substrate. And then really by the time you get to the end, you're gonna have a very little wait time. We actually say this adhesive flashes off within 5 minutes, and that is being generous. Generally, unless you're really applying it too thick, it shouldn't take that long. You get to the end, you might have a little bit to wait, but then you can basically bond that membrane to the substrate. So just a super fast way to do an adhered roof if you have that option. But in any case, due to the fact that it's really got a flash off time of 5 minutes, and by the way, when we say flash off with this, we're talking same thing as the other adhesives. It should be tacky. It should not string or transfer to a dry finger or knuckle touch is how you know it's ready to go. And then I did want to actually go back to these because I realized I forgot to talk about the coverage rate for these ones. So coverage rate for these, you're looking at, we specify it as, you say, 60 square feet a gallon finished surface. So there's 5 gallons to one of these pails. So a lot of roofers know that is 300 square feet per 5-gallon pail, basically. But again, it's a contact adhesive. So there's enough adhesive, for example, in one of these 5-gallon pails, either one of these, to cover if you had a roof that was 300 square feet. If that was the size of the whole roof, you would have enough adhesive to coat both the membrane and the substrate, which again is generally your top layer of insulation. Okay, so for a mechanically attached roof system, there's no bonding adhesive in the field of the roof. So what you have with these is basically these fasteners and plates. I already talked about this a little bit. These fasteners and plates essentially are what secure the membrane on a mechanically attached system. So basically what you see is these are 6 inches on center. Our sheets don't really look like this anymore. They don't have this line going through the center of them that you see right here. It's basically just X's every 6 inch on center. And really, 6 inch on center is pretty beefy. Based on how much wind you would expect, you can go that dense. Most systems, it's every other X, which is 12 inches on center. And what you'll have is that's what secures the bottom sheet that you see right here. But the top sheet basically gets, we call it spliced to the bottom sheet. And that is done with our seam tape. And I'll talk about that product basically coming up. So what it would be is that this top sheet we can splice to the bottom sheet there. And then I just want to talk about that. It's going to kind of continue itself, the process. So you want the seams to basically shed water, obviously. So if the roof was obviously, sloping this direction, then you would want your top sheet, to be overlapping the way that they have it in this image. So basically the top sheet in this particular scenario does not get any fasteners and plates through it. Again, it's just the tape that I'm going to talk about that actually secures it to the bottom sheet. But then the other side of this same sheet does get fasteners and plates in it. And then the sheet adjoining that will get spliced over top of these fasteners and plates. And so it's essentially just a process that continues the same way throughout the roof is how that is supposed to be laid out, basically. So now we have, we'll talk about some of the fasteners and plates. So for EPDM, we have our HPW fastener. That works into steel or wood decks. Okay, we do have some other fasteners and plates available for other deck types, but generally steel or wood are where you see mechanically attached roof systems where there's no bonding adhesive in the field of the roof. It's just the fasteners and the plates. So for this type of system, if it's wood, for example, the 2-inch plate would be fine. But if it's a steel deck, what we found the issue can be if you use the metal, the 2-inch plate, as opposed to this polymer plate that we see right here. What the issue can be there is that you got to think steel is thinner than wood is, for example. So even though it's a strong material, you got to think those fasteners aren't really gripping that much material of a steel deck, for example. So what can happen if this 2-inch seam plate is used on a mechanically attached system like this over a steel deck is when those sheets start to flutter, essentially, because remember, I was saying there's no adhesive in the field of the roof here. When those sheets start to flutter, you can actually, this plate can get a little bit wobbly. Essentially, it can actually start to tilt, to wobble, and basically that fastener can start to back out of that steel deck over time. Over wood decks, you don't have that problem. This plate, if it's put down tight to begin with, it'll stay there. But the problem again is if it starts at all, you know, that fastener starts backing out, it can become a securement issue over time. So these plastic plates that you see right here, these are what we call our polymer plates. And those have essentially teeth on them, and they have essentially made with like a locking mechanism, essentially. So they kind of lock down basically when you drive that fastener head into that plate itself. So they basically are less likely on like steel decks, for example, to back out. So just a reference there as to why on steel decks with mechanically fastened systems, we like to see that polymer plate. And then this is a example of just a ballasted roof, so a ballasted EPDM roof. You can see they're using basically rock here to weight down both the membrane and the insulation, so that weight is actually what secures really the entire system. So it's a very simple system in that concept. Basically for the rock, we say 1.5 inch. We like it to be what we call 1.5 inch nominal water-worn gravel. And we don't like to see real sharp stone. That type of gravel is, it goes through a screening process, and it's not as sharp, for example, so it's not as likely to puncture the membrane. So just an example of the type of stone that we really want to see on like ballast roofs, if anybody had that kind of a system or has that kind of a system coming up. And so there's no fasteners and plates. I just want to reemphasize that with this system. So you don't have anything, any fasteners and plates underneath the membrane. You don't need them. We really don't want them because of that puncture point that they can create. If you have that hard plate right underneath the membrane, basically if people are walking across that ballast, for example, that plate can create a puncture point between the membrane and the stone. Same thing with, if you watch my Insulation 101 webinar that I did, we like to have a softer board for the insulation than like a harder board for that top layer. So like our polyiso product, the 20 to 25 PSI product, would be a better one to use as a top layer for a ballast system. But lastly, we like the ballast to really, we save you 10 pounds per square foot to really apply the right weight over top of that membrane and the insulation. Much less than that, obviously, you start to potentially deal with securement issues. So moving on. So when you apply or when you install the membrane, obviously you have to treat your seams. So I was talking about how if you get any adhesive if you are doing an adhered roof, if you get any adhesive in the seam areas, you want to clean that off. This would be the cleaner that you would use, one of these two. And I'll just talk about the differences between them. If you're in a state that accepts standard weather membrane cleaner, which Pennsylvania, for example, we require low VOC adhesives, but we actually allow, I'm just giving Pennsylvania as an example, we allow the standard weather membrane cleaner. But some states like Utah, for example, they actually require this low VOC cleaner here. So it's really going to be generally depending on what area you're in, on which one of these you would use. If you could use the weather membrane cleaner, you're probably going to, because it's a less expensive product. But anyway, you're going to get about 400 square feet per gallon of coverage with this if you're cleaning the membrane. And then if you remember me talking about the 10-foot or less wide sheets being no dust sheets, basically those are pre-cleaned, you know, so you don't have to clean those sheets at the seam areas unless they've gotten dirty, unless you get adhesive in those areas, or unless, you know, muddy footprints, or if the membrane's been on the roof for long enough that it's just been too exposed to the weather and the elements. So unless it gets dirty, you don't need to clean those seam areas. But the wider than 10-foot sheets, you really should clean those seam areas, because those have that dust on them that I was talking about. That's the dusted sheets. And really the best way to do that is to take like a dry rag, or we sell what are called splice wipes, and you can actually use those to really, or even a broom actually, to really move the majority of that surface coat of dust to the side. And then you could take a splice wipe or a rag and put some cleaner on it and actually clean those seam areas to remove basically that dust before you complete that seam. And the reason for the first step is because if you just take a dry rag or a splice wipe right off the bat and start to clean those seam areas, that dust is going to accumulate so quickly on those rags that you're going to have to either change them out or clean them so frequently. It just helps to basically use something dry for the first step to really move the majority of that dust off those seam areas before you really do give it a thorough cleaning with the weather membrane cleaner, so, or the low VOC cleaner, depending on what area you're in. But that is what you want to do, what we would always recommend on the dusted sheets. So, seam tape, we make it in 3-inch and 6-inch wide. So 3-inch, you know, is fine on like adhered systems, for example, or adhered roofs. The 6-inch tape, for example, we really always like to see that on mechanically attached roof systems. So we'll talk about that, and we'll actually show an example of each here in the coming slide. Well, maybe a couple slides, but the low VOC cleaner, I want to talk about the difference between the low VOC cleaner, for example, and then the this one that we see right over here. This would be our non-low VOC product right here. So the multi-purpose, and basically the low VOC you don't want to stir, and you do want to stir the multi-prime or the multi-purpose EPDM primer. Again, this is a non-low VOC product, the one on the right-hand side. The main reason you don't want to stir the one on the left, and that's kind of not really what most people are used to when it comes to primers, is there's additives in that product that we actually need to make it, or when we're manufacturing it, that we need to make it, but we actually want them to settle at the bottom of the can and to not get mixed back in with the product. So that's not the case with the multi-purpose EPDM primer. We actually want all the additives mixed in. So we actually put a sticker on the low VOC to let people know, you know, don't stir this product, because most people are used to having to stir primer. So that's really the main difference from an application standpoint. You're going to get a little bit more coverage from the low VOC. You'll get, we say, upwards of 700 square feet per gallon on cleaned membrane, as long as it's where you're splicing to is clean. You'll get upwards of 700 square feet per gallon with this stuff, and then you'll get about 450 upwards of that with the standard multi-purpose EPDM primer. And then with primer, you really want to roll it on with like a 4-inch like paint roller, for example, snap. And then you want an even coat, no globs or puddles. So really the same deal as the bonding adhesive that I was talking about so many slides back. So it should be tacky, and it shouldn't string or transfer to a dry finger or dry knuckle touch. So that is how you know it's ready to go. If it over dries, let's say, if it's no longer tacky, you can always apply another coat. So just an example there. All right, so as far as the seams themselves, you can see this image to the left-hand side. That is our field applied seam tape. And then the image to the right-hand side, that is our pre-applied seam tape. Big difference here is that one comes with the tape. This tape right here, the pre-applied, is already applied to the roll in the factory. So that's a big benefit to the roofer on the roof. It saves a lot of steps, and it saves a lot of room for human error as well, with the fact that it's actually on the roll itself. In this case right here, where you can see him, there's actually marks on this sheet. He's already applied the tape, so you can't really see it, but basically what you want to do if you're field applying the tape is you want to basically take the edge of this roll, and that's if you're on the field seams, you'll have a mark to actually shoot for. You basically take the edge of the sheet, and you would lay it. You can actually see an example right here. You would lay it to the outer mark, basically. And then, or excuse me, you would lay it to the inner mark. And then you would make sure, again, our seam areas are clean. You would prime them with the EPDM primer. You would let it get tacky, okay? And then you would apply this tape so that the outer edge of the tape is actually along the outer edge of the outer line, essentially. So your sheet would go on the inner line, the edge of it, and then your tape would go on the outer line. And what that's for, the distance between these two lines that you see, that is actually 1/4 of an inch, because we really like to see tape exposure sticking out of that seam at least 1/8 of an inch, no more than 1/2 of an inch. So we basically put these two marks 1/4 of an inch apart, because that's splitting the difference for the roofer, essentially. But it's tougher than you might think to do, basically. So if you end up getting really wide with the tape, you know, that's what you run into with the potential problem of human error. You know, you can have a seam tape exposure way more than like 1/2 of an inch, and then what that can result in is just not enough tape inside the seam itself. So anyway, going back to the step of after the primer's flashed off, you want to apply the tape, and then you basically take this top sheet, you would fold it over, and then you would actually remove this release liner and apply pressure to that seam. You want to use like a 2-inch roller, okay? And that pressure is really crucial to get that bond between that tape and that EPDM membrane. If you don't apply that pressure, it's probably not going to perform nearly as well, if at all, terms. So a really important step there. And with the factory applied, or with the pre-applied seam tape that's done in the factory, that basically does the homework for you. So you can basically just, all you have to do in that case is prime the bottom sheet itself, and then you can take, you know, the edge of the tape to basically the outer line, and you're good to go. Once that primer on the bottom sheet flashes off, that's really it. You remove the release liner from the pre-applied seam tape and then roll it with a 2-inch roller. So that's the other one. Again, with the field applied, you have to prime both the top and the bottom sheet. You have to prime any surface that tape is coming into contact with, or it's not going to work long term. The other thing you'll see is you want to extend that primer out past the tape. So we always say when it comes to priming EPDM, color outside the lines. We're always taught to color inside the lines. With this, we want that primer to extend everywhere that tape is going to go, and then some. So here you can see if it's a mechanically attached roof system, we want to have 6-inch tape, because that actually creates a much more secure splice, and it gets enough distance past those the edge of the fasteners and plates that you have less potential of a leak, for example. So I'll go back to that securement thing that I was talking about here in just a second, but and then this is an example. They went every other X. That's 12 inches on center. But just another example, they primed the bottom sheet, they primed the top sheet. They're pressing that tape into place so that the outer edge of the tape hits that outer line. You can see this is the inner mark. So you have the same thing on these sheets. You've got an inner mark and an outer mark. Before they started doing this tape, they would have made sure that the edge of this top sheet would have landed on, on that on this inner mark that you see right here. And then again, by landing the edge of the tape on that outer mark, they should have between 1/8 of an inch and 1/2 of an inch of seam tape exposure. Now, what roofers will do sometimes is they'll put these plates, these fasteners and plates, on the back edge of the seam. So they'll actually put them back here, and then they'll apply that tape still out to the edge right here. And the thought behind that is really, it's in a good place. The thought is it's less likely to leak. But the reason we like that tape, or the plates, excuse me, to be really centered underneath of that tape is really securement. If those plates are on the back edge of the seam, for example, that basically puts the seam into a peel mode versus a shear mode. And it actually is much weaker, that seam, if those plates are installed on the back edge. Now, that's not the case for TPO or PVC. Those are different animals. But for EPDM, we always want those plates centered underneath of 6-inch tape. That really is the strongest, best splice. And the other thing, of course, is if they're too far this direction, you know, if you have that plate out here, you don't have much seam tape past the edge of the plate. That's why, again, really centered underneath of that tape is what we're going for. And then just another example of, here you can see this is the pre-applied tape. It's been already applied to the sheet in the factory. And basically it's folded back in this picture, but again, they're only priming the bottom sheet. All they really want to make sure is that that edge of the tape right there is landing on that outer mark. If they go a little bit past that mark, you know, it's really not that big of a deal. It's fine, but we do the homework with the tape exposure for you in the factory. You don't run the risk of having way too much or not enough, for example. So that is it for this particular training. So I want to thank everybody who listened to it, and thank you.